You've probably thought about time travel, right? I mean, who
Yeah.
hasn't? You see Marty McFly trying to fix his family history, or the Doctor in the TARDIS just hopping around centuries. It's sort of baked into pop culture.
Oh, absolutely. It's this really deep human curiosity, isn't it? That urge to explore not just where we are, but when we are.
Totally. And it's not just, fiction. I saw this YouGov survey from 2024.
Yeah.
62% of Americans, like a big majority, said, yeah, they'd time travel if they could.
Wow, 62%. What was the main reason?
Mostly just to see history unfold, just curiosity,
Hmm.
which really makes you think, okay, if we could actually do it, what would really happen? Is there any science to it, or is it all just fantasy?
Well, that's the big question, isn't it? And it leads down some pretty mind-bending paths.
Right. So that's what we're doing in this deep dive. We're going to get into the big stuff.
Yeah.
Paradoxes, obviously the grandfather paradox, the massive energy problems, the technology.
And the theories, too. Yeah, wormholes, time dilation, even quantum stuff and the multiverse idea.
Exactly. And we'll even try a little thought experiment, like a trip to ancient Egypt, see how that might play out.
Sounds good. So the mission is basically to unpack these wild ideas and see what current science actually suggests about whether time travel is, even remotely possible.
Okay, let's jump right in. Because as soon as you think time travel, you almost immediately think problems, logical problems.
Paradoxes, yeah. These logical knots that show just how tricky messing with time would be. They're not just fun puzzles, they hit the core difficulties.
And the most famous one, everyone knows it.
Yeah.
The grandfather paradox. Break it down for us.
Okay, so the classic setup is you go back in time, you prevent your grandfather from meeting your grandmother. Simple enough action.
Seems simple.
But then your parent isn't born, which means you are never born. So who went back in time in the first place? It just sort of collapses in on itself logically.
It's that perfect loop you can't resolve. But I was reading about Germain Tobar, a physicist. He had this paper in 2020 talking about consistency protection. What's that about?
Yeah, Tobar's idea is interesting. It suggests the universe might have like a built-in failsafe against these paradoxes.
A fail-safe? How?
So if you tried to, say, shoot your grandfather, maybe your gun jams, or you suddenly get sick, or a car drives past at just the wrong moment, something intervenes, almost coincidentally, to make sure the timeline stays consistent with you eventually being born.
Okay, the universe course corrects? That's weird.
Mm.
But what does that do to free will? If the universe is just going to stop me anyway, am I really making a choice?
That's the big philosophical question that comes out of it, isn't it? If your actions are always sort of nudged back into line to keep history consistent, how much control do you actually have? Are you really acting freely or just, playing out a script?
Yeah, it kind of feels less like traveling through time and more like being carried along by it.
It definitely challenges our idea of cause and effect and agency.
Now, there's another way people try to solve the grandfather paradox, right?
Mm.
The multiverse idea.
Right, the many worlds interpretation. So the idea here is when you go back and change something like stopping your grandparents from meeting, you don't actually alter your original timeline.
Okay.
Instead, you sort of split off reality. You create a whole new parallel universe where things happened differently. In that universe, you were never born.
Ah, okay. So my original universe is fine, I still exist there, but this new one is created by my action. That seems cleaner, maybe?
It solves the logical contradiction, yeah. But
Right.
the big problem then becomes you're probably stuck in that new universe.
All right.
You've created this reality where you don't belong, and maybe there's no way back to your original one.
Stranded in a parallel world. I saw this post on X from @SciFiThinker, basically saying, if you can't change the past without breaking logic, is time travel even worth it? Makes you wonder.
It really does. Whichever way you look at it, the grandfather paradox just shows how incredibly tangled up cause and effect are. Time isn't just a straight line you can easily edit.
And that tangle leads us to the next big issue, the butterfly effect. The idea that tiny changes can have huge, unpredictable results down the line.
Yeah, coined by Edward Lorenz back in the 60s, talking about weather prediction. But the principle applies, right? Complex systems are super sensitive to initial conditions and history. That's arguably a very complex system.
So give us an example. Like, what if I went back to 1492 and, I don't know, gave Columbus a really bad stomach bug so he couldn't sail? Seems minor, maybe.
Well, think about the consequences. No voyage in 1492 means no European discovery of the Americas at that time. That fundamentally changes, well, almost everything about the last 500 years of global history. Colonization, power balances, culture,
It
economics.
would be a totally different world. I saw the Santa Fe Institute ran a simulation on this exact thing, delaying Columbus.
Yeah, I saw that too from 2024. Their model suggested something like a 70% chance that without that early European expansion and Asian power, maybe China or Japan would have become the dominant global force by now.
Wow. Just from delaying one voyage, it really shows the scale. But some scientists, like Stephen Hawking, thought maybe the universe prevents these huge changes, his chronology protection conjecture.
Exactly. Hawking suggested back in 99 that maybe fundamental physics, perhaps quantum effects, step in to prevent paradoxes or these massive timeline rewrites. Sort of like Tobar's idea, but maybe rooted deeper in physics. The universe protects its own history.
So maybe you can't cause those massive ripples. But then Kip Thorne had a slightly different take, didn't he?
Thorne thought that maybe you could make changes. They wouldn't necessarily create paradoxes, but the effects would ripple forward, creating a new present.
A new present.
Yeah, one that's logically consistent, follows from your change, but is completely unrecognizable compared to the one you left behind. You wouldn't break reality, but you'd end up somewhere totally alien.
Okay, so either the universe stops you or you end up in a future you don't recognize. It's, yeah, a bit daunting. The risk of unintended consequences seems massive.
It really is. You're basically tinkering with this incredibly complex machine without knowing how all the parts connect.
Okay, so the logic is tricky, the consequences are scary. But let's say we ignore all that for a second. What about just building the thing? The technology, the energy.
Yeah.
This sounds like the really hard part.
Yeah, I mean, this is where science fiction often glosses over the details, but these are probably the biggest showstoppers right now. The practical requirements are just, well, they're immense.
Let's start with Einstein. General relativity, right? It suggests time travel might be possible near really massive objects, but the energy.
The energy involved is just staggering. General relativity tells us gravity warps space-time. To warp it enough to create shortcuts, like maybe a wormhole, you need incredible amounts of energy concentrated.
How incredible. I remember Mikio Kaku put a number on it in Physics of the Impossible.
He did. He estimated that creating a stable, traversable wormhole would require something like the energy output of an entire star.
An entire star. Per second, wasn't it?
Yeah.
Like 10 to the power of 41 joules per second.
Yeah, something like that, yeah. An unbelievable number. Compare that to, say, the entire world's annual energy consumption in 2024. That was around, what, 6 times 10 to the 20 joules for the whole year.
So the wormhole needs vastly more energy per second than humanity uses in a year.
Pretty much, yeah. It's almost unimaginable. I mean, we're talking energy levels comparable to a supernova explosion just to potentially open a stable portal.
Okay, so energy is a problem. A huge one. And even if we had that energy, controlling it, building a stable machine.
That's the other side of it. We don't just need the power plant. We need the technology to manipulate space-time fabric in a controlled way. We're nowhere near understanding how to do that safely or reliably.
And it's not just general relativity. Special relativity throws a wrench in the works too, especially for going backwards, right? Faster than light travel.
Yeah, special relativity connects space and time, and it sets the speed of light as a kind of cosmic speed limit. Many theories of backward time travel seem to require going faster than light.
And the problem there is
Causality, the principle that cause must come before effect. If you could travel faster than light, you could potentially send information, or yourself, back in time to arrive before you left. Effect before cause.
which breaks, well, everything we understand about how the universe works.
Fundamentally, yes, it opens the door to all sorts of paradoxes where you could, say, receive a message before it was sent.
Okay, so huge energy needs, requires impossible tech, breaks causality. It's looking pretty grim. But what about quantum mechanics? That's always the weird wild card. Anything there?
Well, quantum mechanics definitely operates by different rules, and there are phenomena like quantum entanglement that are suggestive.
Entanglement, right, where particles are linked no matter how far apart.
Exactly. Measure one and you instantly know something about the other faster than light could travel between them. And some experiments, like one at Cambridge in 2023, showed behavior that looked, well, retrocausal.
Retrocausal, like influencing the past.
Kind of, as if measuring one particle now could influence its partner's state slightly back in time. And a 2024 paper speculated maybe you could, in principle, send information through time using these links.
Okay, information. But that's a long way from sending a person,
A
right?
huge leap, yes. Plus, there's something called the no signaling theorem in quantum mechanics. It basically says, even with Entanger's weirdness, you can't use it to send usable information faster than light.
Ah, so no instant messaging across the galaxy, and probably no practical way to send messages or people back in time using quantum tricks either.
That seems to be the consensus, yeah. As that physics nerd put it on X, the energy costs and paradoxes make time travel sci-fi fantasy for now. Quantum mechanics might hold keys, but we're talking tiny scales and information, not human transport.
Right, so the hurdles are just enormous on pretty much every front.
Yeah.
Okay, but let's not give up hope entirely. Let's dive into some of those theories, even if they are speculative. First up, wormholes, the classic sci-fi shortcut.
Yeah, and like we mentioned, they actually come out of Einstein's theories. Einstein and Nathan Rosen theorized them back in 1935, these bridges connecting two different points in space-time.
So gravity warps space-time, and a wormhole is like an extreme warp, a tunnel.
Exactly, a theoretical tunnel that could link places billions of light years apart. Or
Different points in time.
that's the really exciting possibility. If a wormhole connects two points in space-time, those points could be separated spatially, temporally, or both. Step in here now, step out there then.
Sounds amazing. Okay, what's the catch? There's always a catch.
The big one is stabilizing the wormhole. To keep the throat open long enough for something to pass through, general relativity predicts you'd need something called exotic matter.
Exotic matter, what's that?
It's hypothetical stuff that has negative mass or negative energy density. Basically, it would have anti-gravity properties, pushing space-time apart instead of pulling it together.
Negative energy, does that even exist?
Not that we've ever observed or created in any stable macroscopic form. Sabine Hassenfelder mentioned in a lecture, 2024, I think, that while quantum effects might produce tiny, fleeting amounts, scaling it up to prop open a human-sized wormhole is, well, maybe impossible or centuries away at best.
So we need miracle matter that might not exist. And even if we found it.
Even then, stability is a huge issue. Stephen Hawking argued back in '92 that quantum fluctuations, the inherent fuzziness of reality at small scales, would likely build up near the wormhole entrance and cause it to collapse instantly.
Right, so like a quantum feedback loop destroys it before you can use it.
Potentially, yes. So while NASA might be looking into, the theory of microscopic wormholes as part of quantum gravity research in 2024, a usable, stable, macroscopic wormhole for time travel, still very much theoretical.
Okay, wormholes are maybe out for now. What about time dilation? That sounds a bit more grounded. The idea that time passes differently based on gravity or speed.
Yeah, this one is absolutely real. It's a core prediction of both special and general relativity, and it's been experimentally confirmed multiple times.
How does it work with gravity?
Strong gravity warps space-time more intensely. Clocks deeper in a gravity well closer to a massive object like a planet or a star, or especially a black hole, tick slower relative to clocks further away.
So the classic example, hang out near a black hole, time slows down for you.
Exactly. Orbit a supermassive black hole for, say, what feels like a year to you. When you come back to Earth, decades or even centuries could have passed here. You've effectively traveled into Earth's future.
Like in the movie Interstellar.
Precisely. That movie dramatized it quite effectively, even if it took some liberties.
And we know this actually happens, not just theory.
Oh, yeah. The Hafal-Keating experiment in 1971 is the classic proof. They flew atomic clocks on airplanes around the world.
Right.
And compared them to identical clocks left on the ground. The moving clocks showed tiny but measurable time differences, exactly matching Einstein's predictions for both speed and gravitational effects.
Okay, so time dilation is real. But it sounds like it only goes one way into the future.
That's the main limitation for time travel enthusiasts, yeah. It's a one-way ticket forward, and you need extreme conditions to get a significant effect.
Like a black hole, which isn't exactly next door?
Nope. The nearest known one, Gaia BH1, is over 1,500 light years away. Getting there, orbiting safely, and returning. That's way beyond us.
And the effect on Earth is tiny, right? Like for GPS satellites?
Minimal for everyday life, yeah. GPS satellites experience about 38 microseconds difference per day compared to us on the ground, mostly due to being in a weaker gravitational field and their orbital speed. Crucial for GPS accuracy, but you won't notice it yourself.
So useful physics, but not a time machine to the past, or even practically to the future.
Not really, no.
Okay, let's get weird again. Quantum entanglement. We touched on it for information, but could that somehow be used for actual travel, a quantum leap through time?
This is definitely the most speculative end of things. As we said, entanglement links particles instantly across distance. The really weird part is that retrocausal idea.
Yeah, the Cambridge experiment suggesting influence backward in time.
Right. And the 2024 paper exploring sending information that way, it makes you wonder if information can potentially cross time barriers via quantum links, could something more substantial?
But that jump from information to matter seems like the big problem again.
It is. And the no signaling theorem still applies, likely preventing controlled use for faster than light or backward in time communication or travel. We don't know how to harness entanglement for transport.
So the quantum TARDIS that Quantum Dreamer tweeted about, still just a dream.
Pretty much. It's fascinating physics, pushing boundaries, but connecting it to macroscopic time travel involves hurdles we don't even know how to define yet, let alone overcome.
Okay, theory number 4, the multiverse. Lots of parallel universes. How does this help with time travel?
Well, the multiverse idea, going back to Hugh Everett in the 50s, mainly helps with the paradox problem.
How so?
The idea is every quantum choice, every possibility splits the universe. So if you go back in time and change something.
I don't change my past, I just jump to a different universe where things went that way.
Exactly. You try to kill your grandfather.
Yeah.
You succeed, but only in a newly created parallel universe. Your original timeline where you were born continues unchanged. The paradox dissolves because you never altered your own history.
Okay, that avoids the logic bomb. But, like we said before,
We're stuck there. You've jumped ship to a different reality branch. How do you get back? Can you even get back? The theory doesn't really provide a mechanism for travel between these universes.
so it makes paradoxes less problematic, but maybe makes return trips impossible.
That seems to be the trade-off. And of course, proving the multiverse exists is step one. We have hints, maybe, some cosmic background radiation anomalies, maybe some data from the James Webb Space Telescope in 2024 that some physicists interpret as potential signs, but it's highly speculative.
Right. Not exactly hard evidence yet. Sean Carroll's book argued the multiverse makes time travel safer, though.
Safer in the sense that you don't risk erasing yourself by changing your own past. The consequences are contained in the new timeline you create. But safe doesn't mean practical or even possible to navigate between these worlds.
Gotcha. So another fascinating idea. Solves one problem but creates others and is still way beyond anything we can test or use.
That sums up most of these theories, unfortunately. Intriguing, rooted in real physics, but with massive gaps and challenges before they become reality.
Okay, let's switch gears. Enough theory for a minute. Let's do that thought experiment. Imagine I can time travel. I build a machine, somehow, and I decide to go to ancient Egypt. Say, Giza, 2560 BCE, right when they're building the Great Pyramid for Pharaoh Khufu.
Okay, setting the scene. Thousands of workers, huge limestone blocks, must have been an incredible sight. Hot, dusty, noisy.
Definitely. And my goal isn't just to watch, I want to intervene. I bring back some relatively simple, by our standards, technology. Steel tools, chisels, saws, maybe some basic pulley systems. Oh, and plans for sort of primitive concrete, like the Romans used later.
Okay, introducing 21st century tech into the Bronze Age. What's the immediate impact on the pyramid construction?
Well, the steel tools alone would be revolutionary. Shaping those massive stone blocks, they were using softer copper tools, maybe some stone pounding. Steel would let them cut and shape much faster, maybe 50% quicker.
Huge efficiency gain. And the pulleys.
That tackles the lifting, reduces the sheer brute force needed. Simulations suggest maybe a 30% reduction in labor needed for hauling the blocks up the ramps. And the concrete mix, maybe using volcanic ash like the Romans did, could make the structure even more durable, maybe allow it to be built taller.
So faster, cheaper, maybe bigger and stronger. The pyramid gets finished way ahead of schedule instead of 20 years maybe.
12,
No.
yeah, something like that.
Yeah.
8 years ahead of schedule. Maybe it ends up being 529 feet tall instead of 401. But the real question is, what happens next? All that freed up labor, those resources.
Right. Khufu now has thousands of skilled workers and years of resources available that in our timeline were tied up at Giza. What does he do with them?
Maybe he invests heavily in irrigation, digging canals, improving agriculture. A hypothetical model might show, say, a 25% boost in food production.
Okay, so Egypt becomes richer, more stable, maybe. And that super advanced pyramid, that's going to attract attention.
Exactly. Scholars, traders from Mesopotamia, maybe Crete, it accelerates cultural exchange. Maybe these new tools and techniques spark a kind of proto-scientific revolution. Egyptians studying mechanics because of the pulleys, leading to earlier physics insights.
It could shift the whole societal structure, too. Engineers and builders suddenly become much more important, maybe forming a new influential class, a sort of technocracy challenging the traditional priests.
Yeah, maybe even leading to earlier development of iron tools. Skipping ahead centuries, maybe even 1,000 years before the historical Iron Age really took off there.
But that much rapid change.
But yeah,
It's bound to cause friction, right? The old guard versus the new technocrats.
definitely. Social unrest seems likely. Maybe the priests feel their power slipping, leading to internal conflicts. Could it destabilize the Old Kingdom, maybe cause it to weaken or fragment earlier than it did in our history, say by 2400 BCE, 200 years early?
So accelerated tech, but also accelerated social tension and potential decline. Okay, so you've made your changes. You hop back in your machine, arrive in 2025. What does the world look like?
Probably. Completely unrecognizable. For starters, that enhanced Great Pyramid has stood for 4,500 years as an even more unbelievable monument. It would dominate ancient history studies, inspire engineers globally for millennia.
And the knowledge you introduced, it wouldn't stay confined to Egypt, would it?
No way, it spreads. Maybe Greek thinkers get Egyptian mechanics and advanced math by 1500 BCE, Pythagoras' theorem 300 years early. That accelerates Greek philosophy and science.
Which could ripple forward, maybe an earlier Renaissance.
An earlier industrial revolution. If the scientific groundwork is laid centuries earlier in Greece, maybe Europe sees steam engines not in the 1700s, but maybe 1000 CE, 700 years ahead of schedule.
Wow, okay, and industrialized Europe by the Middle Ages. That changes everything. Global politics.
Europe dominates much earlier, much more completely perhaps. But maybe the Middle East, thanks to that early Egyptian boost, is also a major scientific powerhouse. Cairo as a quantum computing hub in 2025.
And the Americas, with Europe industrializing so early.
Maybe the age of exploration happens differently, or not at all. Perhaps powerful Eurasian empires consolidate much earlier, maybe by 1500 CE. There might be no independent nations in the Americas. The United States might just never exist.
So a totally alien geopolitical map. What about global issues? Climate change.
That's interesting. With science advancing earlier, maybe they developed sustainable energy sources much sooner. Perhaps climate change is less of a crisis.
A potential upside, but the cultural cost.
Huge. Less diversity, probably. A more homogeneous global culture dominated by whichever power got the technological edge first. My little trip to help build a pyramid basically rewrote everything. I'd be a stranger in a world I inadvertently created, with my original 2025 gone forever.
It's a powerful illustration, the sheer interconnectedness. You can't just change one thing.
Yeah, it really slams home the implications beyond just the physics, the ethics, the philosophy. It's heavy stuff.
It absolutely is. The power to change time isn't just a technological challenge, it's an ethical minefield.
Let's go back to Egypt. I intended well, right? Give them better tools, maybe improve lives. But we ended up with potential instability, less cultural diversity. Was that intervention morally right?
That's the core dilemma. There was a 2024 study, I think, in Ethics and Technology, arguing that any time traveler would have a moral duty to minimize harm. But how?
How do you predict the harm? Like our Egypt example showed, the long-term effects are almost impossible to foresee. Good intentions could lead anywhere.
Exactly. Think about the classic example. Go back, stop Archduke Franz Ferdinand's assassination, prevent World War I, save millions of lives.
Sounds good. Seems like a no-brainer.
But World War I tragically spurred certain developments. Maybe without it, the urgent push that led to things like penicillin happens much later, or differently. Do you trade those lives saved in the war for lives lost later to infections?
It's impossible calculus. You just can't know the net effect. The ethical burden would be crushing.
Immense. You're potentially gambling with the entire future of reality based on incomplete knowledge.
And that ties into the philosophy side, too. Free will versus determinism. If time travel is possible, what does it mean for our choices?
Well, if Tobar's consistency protection is real, maybe our free will is limited anyway. The universe forces our actions to align with a consistent history, preventing paradoxes.
So we're not really free, just actors following a pre-written cosmic script.
That's one interpretation, yeah. It leans heavily towards determinism. Or you have the multiverse.
Where every choice creates a new universe.
Yeah.
Seems like ultimate freedom.
Maybe. Infinite possibilities. You can make any change you want. But you're cut off from your starting point. Freedom at the cost of potentially permanent exile.
And then there are philosophers like David Lewis back in the 70s who argued time travel is logically possible, but only if the timeline is fixed. You can go back, but you will fail to create a paradox because events are predetermined to prevent it.
Right. So you can visit the past, but you can't truly change it in a way that breaks logic, which again points towards a deterministic universe where free will might be more of an illusion, especially when time travel is involved.
It really messes with your head. Our whole sense of agency versus this idea of a fixed or self-correcting timeline. Okay, Stepping back from philosophy. Scientifically, if time travel was proven possible, what would that mean for physics?
Oh, it would be the biggest revolution ever. It would mean our current understanding of time is fundamentally incomplete.
Wormholes. Time dilation, they already suggest time isn't just a constant tick-tock. It's flexible, linked to space and gravity.
Exactly. And if quantum entanglement really does have these temporal links, maybe hinting at retrocausality, that shakes the foundations of cause and effect.
I saw the 2024 Nature Physics paper suggesting time might emerge from quantum entanglement.
Yeah.
Like it's not fundamental, but a property of quantum connections.
Yeah, that's a really cutting-edge idea. If time arises from quantum states, maybe manipulating those states could, in principle, manipulate time itself. It potentially connects quantum mechanics, relativity, maybe even the multiverse and interdimensional travel.
It just blows the doors open on our whole model of reality.
Completely. It would force a unification of physics theories and probably reveal layers of reality we can't currently conceive of.
Wow. Okay. And even if it remains theoretical, the idea of time travel has clearly had a huge impact on us culturally.
Oh, massively. From H.G. Wells's The Time Machine over a century ago to shows like Dark on Netflix recently, it's a theme that just keeps grabbing us.
And it sparks real interest. That YouGov poll, again, sci-fi fans thinking it might be possible this century. It fuels imagination.
And that imagination can actually drive science, right? Asking what if about time travel pushes theoretical physicists to explore the edges of known physics, look into wormholes, quantum gravity. As @TimeTravelFan tweeted, the idea itself pushes us to think bigger.
And maybe underlying it all is just that basic human wish, the desire to go back, to fix something, to see something amazing.
That's probably it, isn't it? That deep wish to revisit or reshape the past, whether it's personal moments or huge historical events.
So I guess I have to ask the question, maybe for everyone listening too. If you could go back, change one thing in history, what would it be? Prevent the Titanic sinking. Stop Hiroshima.
Or maybe something more positive. Witness a key historical moment. Attend Woodstock.
Right. But as we've spent this whole deep dive discussing, every single choice, no matter how well-intentioned,
Comes with those unpredictable ripples, those unintended consequences. It's the ultimate double-edged sword.
it really is. Makes you appreciate how complex and maybe fragile history is, how every little thing led to now.
Exactly. The responsibility would be astronomical.
Okay, so wrapping this up, time travel. It's obviously fascinated us forever.
But it's tangled in paradoxes, faces simply enormous energy and technological challenges. Right now, it seems pretty much impossible in practice.
The scientific theories, wormholes, time dilation, quantum stuff, multiverse extenders, they offer glimmers, possibilities, but they're still mostly theoretical, far from reality.
And that trip to Egypt, a stark reminder of how trying to fix the past could just break the present in completely unexpected ways.
Yeah, the ethics, the philosophy, the science, okay, it all forces us to think really hard about what time even is and our place in it.
It brings Stephen Hawking's famous line to mind. Time travel may be possible, but it is not practical.
That feels about right, for now at least.
But exploring these ideas, even if they stay science fiction, is still valuable, right? It pushes our understanding, stretches our imagination.
Absolutely. So the final thought we want to leave everyone with today, if you really could go back, change one historical event, what would it be and why? And what ripples do you think it might cause? Give it some thought.
We genuinely love to hear what people think about that one.
Definitely. And hey, if you enjoy diving deep into the weirdness of time travel with us, please do like and subscribe. We'll be back with more deep dives into other big ideas. Thanks for joining us.